So till now we have understood about how to give the naming for the compounds. So I'll repeat again. Find the longest chain. Longest chain should include all any other functional groups and any other molecules also. After finding the functional group, give the numbering. While giving numbering, you should consider functional group is exist, that should come the less number. And if any bonds are exist, triple bond should get in the less numbering. So in such a way, you have to give numbering. While writing the name, you have to follow the alphabetical order. So whichever is coming. If suppose butane and propane is there, you have to write butane first. Butene or butane, whatever it may. You have to follow the alphabetical order. Coming to the functional group, just now we are talking about functional groups. What are these functional groups? Let us have an iteration about this one. First and foremost thing, it will come in the carbon compounds are halogen group. What are halogens? Chlorine, bromine, fluorine, iodine. These are called halogens. These are group 17 elements in the periodic table. Check this one electron for stabilization. What it needs? All these halogens need 1 electron for its stabilization. If you see this chlorine and methane, so we already understood that for stabilization in the outermost shell, they need to have 8 electrons. For all these halogens, they need only 1 electron to get stabilization. So we can consider it as a formula. Halogen plus alkane give haloalkanes. This is the compound name, we can say it as. If one functional group, that is halogen, mingle with alkanes, that is single bond carbon compounds, halogen plus alkane gives a compound of haloalkane. You need to take halo from halogen and alkane. Alkane name as it is, it will come as the end of the name. That is the compound name. So halogen plus alkane becomes haloalkanes. For example, see here chlorine with methane. Chloromethane. Just now I told you chloromethane. What is the compound name? Chloromethane. In the same way, bromine. Bromine with methane, what will give? Bromomethane. In the same way, fluorine plus propane, what it will give? Fluoropropane. Propane means, as we know that 3 carbons will be there. When it combined with fluorine, it gives fluoropropane compound. Iodine plus ethane. Iodine plus ethane will give you iodoethane. You have to remember how we are giving the name for this functional group and the compound, how it is going to be formed. You have to remember this formula so that you can easily write down the name for this. Any halogen, we know about halogens, chlorine, bromine, fluorine, iodine. Any of these one mingle with alkanes. Alkane may be any member. It may be methane, ethane, propane, butane, pentane, hexane, octane, whatever it may be. When it mingles with an alkane, the compound name will be halo plus alkane name. If it is methane, halo plus methane. If it is propane, bromo plus propane. In the same way, if it is mingled with fluorine, mingled with propane, fluoropropane. This is the halogen name will come first and then the alkane name will come next. The same way iodine mingle with ethane, iodoethane will come. This is how we have to give the naming convention for halogen groups with combination of carbon. See here one example. This is the carbon atom and which is combined with chlorine. One hydrogen is moved from here. So when one hydrogen goes away and chlorine added here, this HCl will form. Then one carbon atom, 3 hydrogen plus 1 chlorine. So this one is chloromethane formula. This is the structure formula and the name is chloromethane. Methane, we know the formula of methane, that is CH4. This hydrogen is replaced with chlorine. So when this is replaced with chlorine, this becomes a chloromethane. Instead of hydrogen, chlorine will become add and the formula of this one is C. How many hydrogens? 1, 2, 3 hydrogens. CH3 plus what is added here? Chlorine. So the formula of chloromethane is CH3Cl. this way you have to understand for all other common. Let us continue with another example. See here in this example 1, 2, 3, 4, 5 and chlorine. So how many carbons are there here? 5 carbons. And alkyl group added here, that is C3H7. And 1 chlorine is added. This is what? Chlorine, chloro, fluoro, bromine, iodine, all these are halogens. So this comes under halogen group. Whenever halogen group is there in the carbon chain, you have to give high priority to that halogen group. So you have to give numbering from here. So in the first carbon, 1 chlorine is added, and in the second carbon, C3H7 alkyl group is added. This is C3H7 is nothing but alkyl, because one hydrogen is removed from alkane, so that C3H7, that is propyl. Propyl is added here. So how to give the name here now? We found already longest chain here. In that 5 carbon atoms are there and 1 chlorine is there, 1 alkyl group is already added. First step is we have to find the longest chain, that is already taken here. Then while giving numbering, halogen group should come first alphabetically. This is the halogen group. So halogen, when we are giving numbering, you have to give first number for the halogen group. You should see that a halogen group should have the less number. While giving the naming convention, while writing the name, you have to follow the alphabetical order. So the name for this one is, where chlorine is added? 1. On 1 chlorine, the first chlorine, you added the chlorine. So first 1 chloro and then 2. 2 what is added? Propyl. In the 2 propyl, and in the carbon chain of 5 carbons. What do you call this 5 carbon chain? Pentane. So all the bonds are single bonds. So N is added. 5 carbons, so that pentane. 1 chloro, 2 propyl, pentane is the naming for this one formula. See here another example. CH3Cl. CH3, 1 Cl. So this is CH3 is what? Methyl. Methyl, when added with chlorine, methyl plus chlorine is added, chloromethane will be produced as the compound. So 1 hydrogen will be removed here. In place of hydrogen, chlorine will come. Chlorine will occupy that one. So chloromethane will be produced. See this example here. In this, how many carbon atoms are there? 1, 2, 3, 4. Why I have given right to left numbering? As previously I told you that halogen group is there, means we have to give less number for that one. So here bromine. Bromine atom is added here. So when bromine added, this is the another group, halogen group. So for this we need to give less numbering. If you count from here 1, 2, 3. On third carbon bromine is added. But if you count from here 1, 2. So 2 is less number. Bromo we have to add. 2 is the numbering. And then 1. In the first place, what are the molecules are here? That is chlorine and chlorine. How many chlorines added here? This is having high priority and chlorine, 2 chlorines are added here. So in the first place, 1 and 1, 2 chlorines. 2 means numerical symbol di. Di, chlorine is added, so chloro. And how many carbon chain, how many atoms are there in carbon atoms are there? 5. So pentane. What is the name for this one? 2 bromo, that is alphabetically bromo will come first. So while writing the name you have to give this one bromo. 2 bromo, 1 1. This is in the first place 1 comma 1. What are there? Chlorines. How many chlorines are there? Dichloro. 2 chlorines are there. Dichloro. In the chain of 5 carbon chain, that is pentane. All are single bonds, so that we are representing with ane. That is alkane group. In the same way, see this example. 1, 2, 3, 4, 5, 6, 7. 7 carbons are there. This is the longest chain and 1 bromine is added and C3H7 is added. This is propyl. So for this, naming this, this one, what you have to do is, if you come from this way, it is getting more number, so we have to count from this only. So here it is 3. Here if you start 1, 2, 3, 4, 5 will come. So you need to give less numbering for the halogen group. So we are giving numbering from left to right. So 3 bromo in the third carbon, bromo is added, and then in the fourth position, how many chlorines are there? 1, 2 chlorines, 4, 4, 2 chlorines, that is dichloro. What is this one? How many carbons are there? 7 carbons are there. So heptane, all are single bonds. So ANE, heptane. Hept means 7. So this is heptane. 3 bromo, 4, 4 dichloroheptane. Let us see this example. 1, 2, 3, 4. 4 carbons are there. 1, 2, 3, 4, 5, 6. So we can say about 6 carbons are there in the longest chain of this carbon. And then in the first position, bromine, 2 bromines are added. So as this is the halogen group, we need to give first priority to these groups. So we should start counting from right to left. So 1, 2, 3, 4, 5, 6. If you take this carbon, only 5 will be there. So that we need to go for this 5, 6. See here C2 is there. So 2 carbons. 1, 2, 3, 4, 5, 6. So we found the longest chain. After that, how to give the naming convention? In the first place, how many bromines are added? This is first priority should go to halogen group, and bromine start in the alphabetical order also. It is the first one. So 1, 1. Why 2 ones are there? Because in the first place 2 is added, 2 bromines are added. So to specify that clearly, we should say that first bromine is added where and the second bromine is added where? Both are added in the first place. So you have to consider 1, 1. How many bromines are added? 2 bromines. So dibromo. And then in the second carbon, what is added? Fluoro. Fluorine is added. In the second place, fluorine is added. And in fourth place, what is added? Fourth, methyl. Methyl is added. C2H5 is methyl. Then what is this? 6 carbons are there. When 6 carbons are there, what is the naming convention we have to follow? Hexa, hex. Hexa is added, and ane. Because all are single bonds, we have to specify single bonds with alkane. This is the alkane member name, and this is the family name. Ane is the family name. So for this you need to read out 1, 1 dibromo, 2 fluoro, 4 methyl hexane. By reading this one, we should understand that in the hexane, that is 6 carbons chain, in the first place 2 bromos are added, and in the second carbon fluoro is added, and fourth carbon is having methyl, that is C2H5. In this way you have to understand the naming convention. Till now we discussed about halogen group. There are another functional groups. The second functional group we can consider it as alcohol groups. Alcohol groups contains OH. This is hydroxyl and hydroxide. 2 categories are there in the alcohol group. OH plus carbon will give a new structure for the carbon atoms. OH plus carbon gives new structure, so that new form will be developed. In the carbon chain, if OH is added, then it gives the alkanol. It means that alka is member name, and OL, alkan plus OL. OL will be added for the functional group. So alkane plus alcohol together will give alkanol. What do you say this one? Alkanol. It means alkan plus OL, alkanol. See here in this example, take the oxygen atom and it is combined with single bond with hydrogen, and if it joins with a carbon chain, what will happen? This OH, methane. Methane is the alkane, and adding OH. This is nothing but alcohol group. When methane combined with alcohol, that is methane formula is CH4 with the single bonds 4 hydrogens to fill the gap of 4 valency. Then CH4 plus OH, that is alcohol, is added. Then one hydrogen will be removed from here, and then instead of hydrogen OH will be added. Here CH4 minus H, then CH3 OH will be formed. This is methyl alcohol. Methyl alcohol or methanol. As I told you, we need to take the naming convention of member name plus OL. So, methan plus all methanol. Or else we can also call it as methyl alcohol. See another example. Here two carbon atoms are there. This is methane and this is ethane. Ethane plus OH, how it will form? One hydrogen will be removed, that is C2H5, then OH will be added to that. This one, what do you say this one? Ethane plus OH, ethanol or ethyl alcohol. We can name it as anything. Ethanol or ethyl alcohol also we call. The rules for naming convention, that is nomenclature, is first of all we need to find out, so since from the beginning we are studying that, find the longest chain and with OH group. Here we have to give priority for OH group so that you should not eliminate the OH group. The longest chain should be included the OH group. Must include the OH group carbon. So whatever the carbon, whichever the carbon is having OH, that should be considered in the chain. Without that you should not count the longest chain. See here, if this is the carbon's longest chain, 1, 2, 3 and here 3 are there. So total together 6 carbons. This might be the longest chain if you consider without OH. But we need to consider the OH group, right? So this is not the right format. This is wrong. So we need to consider the carbon which is having the OH group. So you need to start counting from here. 1, 2. This is having OH group. So this is considered in the chain. So this is right practice. 1, 2, 3, 4, 5, 6. This is the longest chain. This way you need to find out the longest chain. In the second step, you need to start counting. Start from OH group. While giving counting, you have to start from the OH group. It should follow alphabetical order. So OH group should get the less number, and while giving naming convention, you have to follow the alphabetical order. See here, in the second position OH is there if you count from the right to left. In the same way, if you start counting from left to right, 1, 2, 3, 4, 5, it is having 4 number. Comparatively, 2 is preferable. That is right to left. So if you count right to left, it is getting 2, so that less number is preferable. Take that sequence, whether it is right to left or left to right, whatever it may be. Whichever is getting OH group less number, that you have to consider. Then, give the naming for this one. All are single bonds. So, alkane family. So, how many carbons are there? 1, 2, 3, 4, 5 carbons are there. It means that pentane. In the pentane, where OH group is added, that one we have to mention. Pentane 2, in the second place, OL is added. OH is nothing but alcohol. When alcohol is added, what is the naming convention? You have to add OL for that. Pentane 2 all. This is where you have to give the naming convention. See here, another rule. When OH, alkyl group or halogens are there, then priority should be given in such a way that you have to give first priority to alcohol, then halogens, then alkyl group. So, what is this priority? For numbering. For giving number to the carbon atoms, you have to follow this priority. First priority should goes to alcohol, then halogens, then alkyl group. See this example. How many carbon atoms are there? 1, 2, 3, 4, 5, 6. 6 carbons are there, and in the end OH is added, that is alcohol is added. So, first priority should go to alcohol, that is an alcohol group. So, then we are going to start the numbering from this carbon, that is right to left. 1, 2, 3, 4, 5, 6 and 7. If you take this carbon, this is only 6. So, we are moving to this one. 6 and 7. So, this is the 7 carbon chain. 7 means hepta. Hepta means 7. So, heptan plus it should end with the ol, heptanol. So, and then we have to mention while giving the naming convention, as I told you, you have to follow the alphabetical order. While giving the numbering, you have to give the numbering based on this priority, that is alcohol group, halogen group and alkyl group. Now we have given numbering, we found the longest chain. Then giving name to that, you have to follow that first numerical value, that is where. And bromo is added. Here bromine is added at the fourth carbon, and so we have to represent the number and bromo. What is added at that place? Fourth carbon, bromo is added, and at the place of 3, after B what will come? What is the letter will come? C. So we are following the alphabetical order convention, order for giving the name. 4 bromo, 3 chloro, then 5 methyl. 5 methyl. What is the chain of the name? Heptanol. Heptone plus all. All is why it is added? Because OH group. That is nothing but alcohol. Heptane means how many are there? 7 carbons are there. So you have to give name in such a way. 4 bromo, 3 chloro, 5 methyl heptane. See this example. 1, 2, 3, 4, 5 carbons are there. You check the numbering for this one. 1, 2, this is the longest chain. There is no other option. 1, 2, 3, 4, 5. Here priority should goes to alcohol group first. So if we count from right to left, it is having 4th place. If we count from this side, 1, 2, it is getting 2nd place. And 3rd also, another 3rd also, one more OH is there. And then chlorine is also added. This is halogen group. What did I told you? Alcohol, then priority goes to halogen. So, if you check here, 2 OH is there, 3 OH is there, and on the 4th place chlorine is there. 2, 3, diol. Diol is there. In the 4th place, chlorine is there. So, how do you give a name for this? 4 chloro. Because alphabetical orderly, C is here. C is first. So 4 chloro, penton. This is 5 carbons are there. So penton, and 2, 3 positions. Diol is there. Pentanol. So that we are giving name like this. 4 chloro, penton, 2, 3 diol. This is the way you have to remember how to give naming. This is how you have to give naming. See here another example. 1, 2, 3, 4, 5, 6. 6 carbon chain. In that 6th carbon chain, OH group we need to give first priority. This is so you have to start from left to right. 1, 2, 3, 4, 5, 6. So 6 is there. 6 means hexa. We have to remember that hexa word. Then bromine included longest chain. So bromine also included, alcohol group also added, everything is added. So this is the longest chain we found. Count OH group pass first. So OH group passing first. So we are giving numbering with this one. See here 2 and 4. Then giving naming, you have to see the alphabetical order. So bromine will come first. So 2 bromines are there. On which positions? 2 and 4. Dibromo. 2 bromos are there. So numerical presentation of the 2 is dibromo. Then in the 3rd place, what is there? That is ethyl. Ethyl. C2H5. 3 ethyl. And then this one is covered, this one is covered, this one is covered. And one OH is added. Hexan 2-ol. Where this OH is added? 2. So hexan 2-ol. This is the way you have to identify how to give naming. Another example, see here. 1, 2, 3, 4. Why I am giving one number here? Because it is having 2 OH, that is alcohol. We have to give priority to the alcohol group first, then halogens, then alkyl group. See here, if you write this 1 chloro, because this is alphabetically comes first, 1 chloro, then F will come, fluorine, 3 fluoro, then 2 propyl, that is 2 propyl, C3H7. Propyl represents prop means 3, C3H7, 3 propyl, I hope you know about propyl. I already explained about how it will come. Alkane minus H will give alkyl. That is the formula. See here C3H8 minus H will give you propyl. That is C3H7. In how many carbon chain? 1, 2, 3, 4. 4 means butane. Buton. When we are giving alcohol name, you have to give the naming convention accordingly. Buton. And it means that 4 carbon chain. First place 1, 1. What is there? 1, 1, and even in the fourth place another OH is there. How many OHs are there? 3 is there total. Where those OHs are placed here? 1, 1, fourth position. So mention the numerical value. So together, all together how many? 3 means triol. I hope you understand this. 1 chloro, 3 fluoro, 2 propyl, butan, 1 and 4 triol. Consider this example you have to find out right now. Till now we have seen only single bond. Here double bonds also present. Provide naming for this. So when chlorine is added here, bromine is added, chlorine is added. So we need to consider naming convention from here. And while giving numbering, you have to consider that double bond should get the less number, and as well as we know the priority of giving alcohol group is present and halogen group present. Here halogens are present here and double bond is here. So if we count from here, double bond will get more number. So you have to consider from right to left. 1 chlorine, 2nd chlorine, 3rd chlorine, 4, 5, 6, 7, 8 chlorine. 8 means octa. That is octane. We cannot say octane because 2 double bonds are there. Ane means it should come only with 1 bond. So when 2 double bonds are there, at least what is the priority for alkenes? At least 1 double bond should be present in between 2 carbons. So here 2 double bonds are there. This is alkene. See, observe here 8 carbons, so octa plus it is ene. And where are the double bonds present? 1 first position and the 4th position double bonds are present. So give naming now. From here 1, 2, 3, 4, 5, 6 because B is the alphabetically coming first. Then the C will come. So we have to give 6 bromo. And chlorine is present where? First place and 7th place 2 chlorines are present. So 1, 7 dichromo and oct because this is having 8 carbons oct. Then 1, 4 diene. First position and 4th position there is a double bond that we are mentioning with diene. See another example. Here also 2 bonds are present, 2 double bonds are present. Give naming convention to give less numerical value to the double bond. So you have to start from right. So first 1, 2, 3, 4, 5, 6. In the first place 1 fluorine is added, in the 4th position bromine is added, in the 5th position iodine is added. And in 1 and 3 places double bond is there. So total 6 carbons, that is hexa. First follow the alphabetical order. First is coming bromine, 4 bromo, then A, B, C, D, E, F. Fluorine will come, 1 fluoro, then that is I. In the 5th position, 5th iodo. In what chain? 6 carbons chain, that is hex. Then 1, 3, what is there? Diene, double bond is there. This is how you have to explain the name. See this example also here, triple bond is there. Whenever triple bond or double bond is appearing in the chain, you have to give less number for the triple bond. You have to consider the priority for triple bond first, and that carbon should get the less number. Pentane means only single bonds. Pentene means double bonds are there. 1 triple bond is there, pentyne. So, in the first position 1 chlorine is added. 1 chloro, because C comes from first in the alphabetical order. 1 chloro, then pentan. Pent means 5 carbons are there. After that, where ion is established? In the 2, 4 diene. 2, 4 diene. Sorry, 1 in the first place and 1, 2, 3 third place diene is established. See here, this is the first carbon, triple bond. This is the third carbon, triple bond. So 1, 3 di means 2 bonds are there. Bonds are which kind of bonds? It's a triple bond. Like this you have to write. Simply you just remember, find the longest chain and give numbering according to the priorities what we need to follow. If alcohol group is there, that one first priority, then halogens, then alkyl group. Then after giving priority, go for the naming convention. While giving naming, you have to follow the alphabetical order. You can say that this pent or oct, all these are root words, and prefix, suffix. Prefix, while adding prefix, you have to give the first number. Then if any double or triple is there, you have to numerical value of that one, and after that numerical expression of that one, di, tri, tetra, like that. Then give the whatever is added, any functional groups or any molecules of other atoms or anything is added, you just mention them with the positions where it is added, and then the root word, and then the suffix, prefix, root word, suffix. Everything need to be followed. Whenever other molecules are present, you have to mention with the numerical value. Similar kind of bonds or something is available in that chain, you have to mention with di, mono, di, tetra, tri, like that you have to mention based on the added things. See this example, you have to take, this is the longest chain, C2, that is 1, 2 carbon, 3rd carbon, 4th, 5th, 6th carbons. In this, OH is added, that is C2H5 is also added. What is this C2H5? Ethyl. Then one chlorine is added here, that is in the 4th position. So how many 6 carbons are there? Bromine is added or not? 6th place bromo is added. So alphabetically while giving name, 6th position bromo, 4th position chloro, hexane, hexanol. Alcohol is added, no? You have to change the name accordingly. Hexane 3-ol. The 3rd carbon OH is added. If we give name numbering from here, OH group we need to give high priority. While giving number 1, 2, 3, 4 will come. If we count from this side, it is taking 3 numbers. So less number is preferable always. So that we are giving in the right to left numbering. See this example. 1, 2, 3, 4 carbons are there. And OH group is added. If we count from here, 2 OH and then 3 OH is there. And then 2 bromo is also added. And fluorine is also added. Alcohol group we need to give. In whichever manner you take, it will come same position. Here 1, 2. Here also 1, 2, 3. 1, 2, 3 it will come. So 2 bromo in the second place. Consider this way. 2 bromo, 4 fluoro, A, B, C, D, E, F. 4 fluoro, butan. 4 carbons are there. So you have to call it as butan. And wherever all is present, mention the numbering 2 and 3 positions. Diol, 2 ols are there, that is 2 OHs are added here. So diol. Hope you understand how to give nomenclature for any carbon chain. The next group is aldehyde group. What are aldehydes? Aldehyde groups and ketones group. What are aldehydes? Alkane plus aldehyde gives alkanal. One carbon atom, one oxygen atom mingling with one carbon atom and one oxygen atom with double bond leads to aldehyde group. See in this example, one carbon, generally a carbon is having 4 hands, that is 4 electrons needed. One is attached with hydrogen and one is attached with oxygen and another one is attached with H. So when hydrogen is removed, it will go with oxygen double bond. Then aldehyde group will be formed. When hydrogen will not come, it will automatically mingle with oxygen and make a double bond between carbon and oxygen, so that it makes a ketone group. This should be always at last of the carbon chain. This will be always at the last of the carbon chain only, because it is replacing someone. If nobody comes, it mingles with the oxygen. Then the bond will be satisfied. Then the outermost shell of the carbon will be satisfied by making the double bond with the oxygen. See with better examples here, so that you will be understanding in a better way. Alkane plus aldehyde, what it will give? Alkanol. Alkane plus aldehyde give you alkanol. For example, methane, we know that alkane. Methane with aldehyde, what it will give you? Methanol. Then ethane also it's an alkane. Alkane mingled with aldehyde, what it will give you? Ethanol. Propane will give you propanol. See the structure of that one. One carbon atom, here one hydrogen is there and second hydrogen is there. Then no hydrogen is available here. When it is mingled with O, that is when it is started with O, one bond. When hydrogen atom is not available, it makes double bond with oxygen. So that HCHO, that is methanol, will be formed. In the same way, in the methane only one carbon is there. If you see the ethane, there are two carbon atoms. As I told you, it always form at the end of the chain only, because when hydrogen is not come to share its electron, then only it will make double bond with the oxygen. In this example, 4 electrons are satisfied with this carbon velocity, and we here 1, 2, 3 is satisfied and no hydrogen came to share its electrons, so that carbon make double bond with oxygen, so that ethanol will be formed, that is aldehyde. CH3 CHO will be formed, that is called ethanol. All will be added for aldehydes. See this example. This is propane. 1, 2, 3 carbons are there, so that it is propane. When it is come across with the aldehyde, when hydrogen not yet come with the carbon atom, then it makes a double bond with oxygen. This will be appear always at the last of the chain, at the end of the chain only. So this one C2H6CHO. C2H6CHO will give you propanol. This is the chemical formula for propanol. This is the way aldehydes will get clubbed with the carbon and give a different compound. Let us come to ketone group of members. The basic formula is alkane mingled with ketone. Alkane plus ketone is equal to alkanone. What is alkanone? Alkane can be methane, ethane, propane, butane, pentane, hexane, octane, nine, and decane. Whatever it may be. So methane plus ketone will give you methanol. And propane and ketone, what it will gives you? Propanol. This is the naming convention you have to remember. When alkanes mingle with ketone, you have to specify with member name plus on. Alkane name plus ONE should be added. Here, carbon made double bond with the another atom which is available here, that is oxygen atom. Carbon plus double bond. This double bond always comes at the end. In general scenario, always it will come double bond ending with oxygen will be coming last of the carbon chain. But there are some exceptions. Let us see these examples. See hydrogen. When hydrogen is not coming forward to give its electron, to share its electron, then it will make double bond with the oxygen. You see in this also, in the carbon chain of these 2 carbons are available and hydrogen fulfilled for this carbon, and this carbon no hydrogen came, so that it made double bond with oxygen. So what is formed here? CH3CHO is formed. This is ethanol. What is this name? Ethanol. See here, this is the propanol. 3 carbons are there. In these 3 carbons, this carbon is satisfied and this carbon is also satisfied. In the second carbon, it is not satisfied. When no hydrogen is coming forward to get its electron, it made double bond with oxygen, so that propanol will be formed. Here, it's not coming in the end, even though it is right. So there are some exceptions. Generally, carbon with double bond with oxygen will come at the last of the chain. Let us see chemical properties of carbon compounds. The first property is combustion, then coming to oxidation, then addition reaction and substitution reaction. These are the 4 major properties of carbon compounds. Let us see what is combustion. In the combustion, carbon compound undergo combustion reaction to produce carbon dioxide and H2O with the evolution of heat and light. So in the reaction process of combustion, it releases carbon dioxide and H2O with the evolution of heat and light. If you see the formula CH4, that is methane plus oxygen O2, it gives you carbon dioxide and H2O plus heat and light. Coming to the oxidation, if you take ethanol, that is CH3CH2OH, if you add KMnO4, that is oxidizer here, KMnO4, it gives you ethanoic acid, that is CH3COOH. The substances which are used for oxidization are known as oxidizing agent. The examples of oxidizing agents are alkaline KMnO4 and then acidified K2Cr2O7. These are the oxidizing agents. Coming to the addition reaction. What will happen in the addition reaction? Unsaturated hydrocarbons like alkenes and alkynes undergo addition reaction in presence of catalysis. Unsaturated hydrocarbons like alkenes and alkynes, which are having double bond and triple bond, will undergo addition reaction in the presence of catalysis. What is catalysis here? See in this example, C double bond C are undergone with additional reaction, and what it formed? Hydrogen is added here, and which gives you C single bond with hydrogen atoms. And substitution reaction. What is this substitution reaction? Saturated hydrocarbons, that is alkenes, give substitution reaction, that is example for this one is methane in presence of sunlight undergo chlorination process. This is the best example for substitution reaction. If you see some other carbon compounds like alcohols, alcohol properties may be, alcohol we used to call as ethanol. Ethanol in regular terminology we used to call as alcohol. This reaction with sodium will what will give you? 2C2H5OH, that is alcohol, ethanol will be added to Na, that is sodium. It gives you sodium ethoxide, that is C2H5ONa, and it will release the hydrogen. So this one we can call it as dehydrogenation. And alcohol, that is ethanol, will be reacted. Alcohol in reaction with concentrated H2SO4 will give you C2H4, that is ethane plus water will be released, H2O. Alcohol can be used as a fuel. In the petrol, 20% of the mixture will be ethanol. What are the harmful effects of drinking alcohol? If we drink alcohol that is concentrated, it leads to death. Some impurities also, it gives you a major injuries to sight and all other problems will come. Even liver also will be affected. And what are the functions of these aldehyde groups and carbon with combination? In regular basis we will come across so many carbon products, like when we are taking bath, when we are washing our clothes, when we are cleaning our vessels, we will come across these soaps and detergents. What are soaps? Soaps are mainly sodium or potassium salts of long chain of acid carboxylic. Soaps are sodium or potassium salts, long chain carboxylic acids, and detergents are made up of ammonium or sulfate salts of long chain carboxylic acids. How these soaps and detergents will be useful to clean the dirt on the clothes? What is the process going on over there? That we will discuss in next video. Before moving to that, I would like to give a glance about all the lesson. Carbon and its compounds. Carbon will be available in free state and combined state. Free state means it is available in crystalline, that is graphite, diamond and fullerenes. In the graphite, triple bond will be there. Diamond is formed with tetra bond, so that it is very strong because of this tetra bonding. And fullerenes, scientists fullerenes found 60C components of this carbon, so that they gave the name of that scientist. And amorphous, free state of carbon will be available in this form as well, that is coke. Amorphous means coke, coal, charcoal and lamp black. All these are amorphous. Coming to the combined state, now we have seen free state, that may be graphite, diamond and fullerenes, amorphous like coke, coal, all these things. Coming to the combined state, it can be available organic and inorganic. Organic means living organisms will participate in the organic matter, and non-living things will participate in the inorganic matter. Coming to the organic compounds, hydrocarbons are there, non-hydrocarbons are there. Hydrocarbons means hydrogen and carbon will be there. Non-hydrocarbons means except hydrogen, other groups will be added to the carbon. In the hydrocarbons, we can mainly categorize into two, that is saturated hydrocarbons and unsaturated. Saturated means alkanes, unsaturated means alkenes and alkanes. Saturated hydrocarbons are having single bonds and unsaturated hydrocarbons can be have double bond or triple bond. If those are having double bond, that is alkenes. If they are having triple bond, at least one triple bond, those are called alkynes. Non-hydrocarbons are like alcohols, esters, carboxylic acids, and natural polymers, lipids. All these comes under non-hydrocarbons because no hydrogen is here. So already explained about hydrocarbons, and this carbon can be available in different forms, chain or branching or cyclic process. So acyclic or aliphatic. Acyclic or aliphatic means it's not forming cycle. The carbon atoms not forming cycle. Under this category only these alkanes, alkenes and alkynes will come. Coming to the carbocyclic or cyclic means carbon atoms will form a circle, that is closed path. Then we can say it as cyclic. This should be prefixed with the name cyclo. This prefixed with the name cyclo. Under this carbocyclic or cyclic, there are two main categories: alicyclic, aromatic. In the alicyclic, cycloalkanes and again cycloalkenes, cycloalkynes also available. Cycle means here it will round the chain and in this branches will come. General alkanes, alkenes and alkynes. And you should remember that based on the number of carbons you have to give the name. If one carbon present methane, if two carbons eth, if three carbons prop, if four carbons but, if five carbons pent and if six hex like that hep, oct, non, dec, undec, dodec. Like this you have to give the naming based on the carbons present in that. And while giving nomenclature for carbons, see here there is IUPAC naming convention. Based on that you have to give based on the carbon atoms. Root word will be meth, eth, prop, but, pent, hex, hept, oct, non, dec. These are the root words. So IUPAC name will be if one carbon present methane, ethane, propane, butane, pentane, hexane, like that it will come. See the structure here, CH4, CH3, CH3. You can see the structure here. And the molecular formula will be CH4, C2H6, like that. See nomenclature of functional groups here. If the functional group is halogen, you have to prefix chloro, bromo, iodo, like that. Here the given example is chloropropane because three carbons are there, one chlorine is there, so chloropropane. All are single bonds, so that propane. The same way bromopropane. Bromine is added, so bromopropane. The next functional group is alcohol group. Alcohol group, you need to add suffix ON. See here, three carbons are there, so propane plus OH added, so propanol. And the third group is, that is functional group, aldehyde group. For aldehyde group, you need to add suffix Al to the given name. So here also three carbons available, so it is propane and Al need to be added, propanol. Then ketone group. For functional group ketone, you need to add suffix 1. Same example, three carbons with one oxygen double bond, propanon. What is ONE should be suffixed with that propanon. The next functional group is carboxylic acid. For carboxylic acid, we need to suffix OIC acid. For doing the same, here at the end of the carbon, one oxygen with double bond and one OH is added here. This is carboxylic acid. So, propanoic acid. This one we have to name it as propanoic acid. Let us see double bonds. Double bond means that is alkenes. Suffix should be -ene. When one double bond is there in two carbons, we can say that that is alkenes family. This is propene formula given here. If triple bond is there, alkynes, alkyne families, YNE should be added. At least one triple bond should present in between two carbons. So one is present here. This is called propyne because three carbons are there and remaining all hydrogens. propane. This one is called as propane. See the structure of alkanes, alkenes and alcohols, carboxylic acids. Alkanes all are having single bonds. This is methane 1 carbon, ethane 2 carbon, propane 3 carbon, butane 4 carbon, pentane 5 carbons. All are filled with hydrogens. These are hydrocarbons. Coming to the alkenes, at least between two carbons, one single double bond should be there. See, ethene. Eth means two with double bond, so E and E is added. Then 3 carbons propene, 4 carbons butene, 5 carbons butene. Coming to alcohol group. In the same way, alkynes, if one bond is present, one bond is triple bond, then we can say it is alkynes. Ethyne, propyne, butane and pentane. Like that, you have to give alkynes names. See here, alcohols are there. Alcohol means OH group should be added. One carbon with OH, that is methanol. OL should be added as a suffix. Ethanol, propanol, butanol, pentanol. This is where we have to give name for the alcohols. See for carboxylic acids, one double bond with O and COH is there. Like this, carboxylic will be there. Ethanoic acid, it is the acid we need to add OIC acid. Same way, propanoic acid because 3 carbons are there, and butanoic acid because 4 carbons are there. This is the carboxylic acid. And pentanoic acid, 5 carbons are there with the carboxylic acid. This is the way we have to name the compounds. See some more examples for alkanes, how they are giving. 1, 2, 3, 4, 5, 6 carbons are there. So hex, ane, all are single bonds. And in the fourth position, 1, 2, 3, fourth position, ethyl, 2 methyl, 4 ethyl, because E will come first in the alphabetical order. So 4 ethyl, 2 methyl, hexane, all are single bonds, 6 are there, so hex plus ane, hexane, 4 ethyl, 2 methyl, hexane. See this example, 1, 2, 3, 4, 5, 6, 7. This is the longest chain we have to find out. 1, 2, 3, 4. 4 ethyl, 1, 2, 3, 4 ethyl, 3, 3 dimethyl, 1, 2 dimethyl, heptane, 7 carbons are there, so that it is heptane, all are single bonds, so that ane. See this one, it formed as a cycle. What are there? This is methyl. Methyl cyclo means it is formed as a cycle. It is a closed one. Cycle. Propane, how many carbons are there? 1, 2, 3 carbons are there. So propane. See this example. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbons are there. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to give numbering from right to left. 5 sec butyl, 2, 7 dimethyl nonane. See this is methyl cyclopropane. Total chain. See this one, CH3, CH2, this one 1, 2, 3, 4, 5, 6. 6 carbons, so hex. 3 ethyl, 1, 2, 3. 3 ethyl, 4 methyl, 4 methyl hexane. 3 CH2, CH3 is there. So 3 ethyl. 3 ethyl, 4 methyl hexane. Like this, you have to understand the concept of carbon and its compounds. I hope this video will be useful for you to have a good idea about carbon and its compounds. Thank you.